everyone, and welcome to another episode of SAF Insights. Today we'll be talking about new technologies like power-to-liquid SAF and direct air capture, and more generally about the journey to get a new production plant off the ground. I'm Giulia Squadrin, Associate Editor for Argus Biofuels, and joining me today are Sophie Zienkiewicz and Alasdair Lumsden, co-founders of Carbon Neutral Fuels, CNF. Hi both, thank you very much for joining us today.
Hi, thank you for having us.
Yeah, thank you both. So let's just jump into it. So CNF and its partners are developing a power-to-liquid and direct air capture SAF project in the UK. Could you tell us a little bit more about it?
That's right. So we started Carbon Neutral Fuels around just under 2 years ago, and we came from outside the industry, and we really wanted to tackle a big problem, and that big problem is climate change. And we saw the power-to-liquid market as a really fantastic opportunity to create impact and also just help contribute to that problem. And so we formed a consortium, and it involves Carbon Neutral Fuels. We've got a fantastic direct air capture supplier, Emission Zero Technologies, and we have a wonderful engineering team called IO Consulting. And together we put in a joint application to the Department for Transport's Advanced Fuels Fund. And we were successful in that application, and we've since been designing a power-to-liquid e-fuels facility, which will be located in the UK, as you said. In terms of the scale, we're looking at 25,000 tonnes per year of SAF being produced. We're currently in the early concept design stages, which is an exciting place to be because you've got loads and loads of questions and loads of answers. So we're currently working through all of those different thought processes now. And so we're working on the site selection, and we're understanding the regulations and the approvals that we're going to need to get in place, and also working out all of the partners and the strategic companies that we need to liaise with to get this project off the ground before 2030.
Great, thanks, Sophie. I think it's always a bit of a process to get new projects off the ground, and especially with new technologies. So what are the challenges that you have been facing in this regard? Especially, again, it's a new plant, and also we're talking about a relatively new technology, especially if we consider that most of the existing SAF production is for HEFA or co-processed material today. So has the novelty of this production pathway proven to be a challenge, or have you been able to find sufficient public and private support to progress with the project according to plans?
Yeah, so actually there are challenges, but we've been really fortunate in our journey so far. So we started the business around 20 months ago, back in September, and we initially started thinking we're going to try and do absolutely everything, but we worked out that there's some really great companies out there that already exist, that the value in bringing SAF, power-to-liquid SAF, to the UK market is in bringing everyone together to create a complete supply chain rather than us developing our own technologies. And so in terms of challenges, that's actually been quite a nice win technology-wise for us, because our fantastic vendors have already done the technology development, and so our job is to integrate that together. And when we're thinking about the UK site specifically, the availability of green electrons is something that we do definitely see as a challenge. And so by that we mean, how are we actually finding the power to power our power-to-liquid facility? And another challenge that we've faced is around supporting investors to understand our technology and our process. So this is a really new space, and so when we're talking to VC funds and strategic investors, it's really new for them too. So our opportunity is to help them become a bit more versed in the world of power to liquids. But so that's been difficult to actually achieve.
I could also add something in terms of the challenges we've been facing. One of the nice things about power to liquid is that although it's a novel pathway, a lot of the technology pieces that we're looking at are quite well established, and the technology speak for this is the technology readiness level. And some of the technologies we're looking at, maybe they're slightly a lower TRL, like 6, 7, or 8. The direct air capture piece, for example, that's relatively novel and relatively new, but that is approaching commercial scale now. That maybe wasn't the case 5 years ago. The other thing that we're looking to do that's quite novel with our facility is make use of solid oxide electrolysis for producing our hydrogen and also producing our syngas, the carbon monoxide component. That's quite novel, and that is approaching a mature TRL. But if we tried to do this a couple of years ago, that wasn't the case. And so we kind of see this as a lot of the technologies are now coming together and the stars are aligning to make power to liquid possible.
Thanks. That's actually very interesting. I don't know, in my mind, I always felt like the technology was still very much under development, but no, it's very interesting to hear that actually it's all coming to fruition. And I think legislation also possibly does help in that regard to give some certainty to the market. And I mean, I'd like to hear your thoughts on that as well. I mean, we have the EU with a sub-mandate for synthetic SAF starting from 2030. And the UK very recently published a mandate, which is still subject to parliamentary approval, which also includes a PTL target from 2028. But the production of this synthetic aviation fuels is still limited, although, I mean, as you mentioned, the technology is getting there and it's very much under development or developed. So in your view, do you think the capacity will be scaled up quickly enough to meet these upcoming targets, or what are the key hurdles to unlock greater PTL SAF production?
That's a really good question. So at the moment, the total amount of SAF that's currently being supplied is less than 1% in the UK. And as you say, it's likely that because of these mandates that we'll need to get to 10% by 2030. So it really doesn't leave that much time at all to actually scale up and grow these facilities that are either in development like ours or under construction. So yes, I suppose 10% of SAF does still feel like a tall order. And in terms of the challenges to actually achieving that, I think unlocking the finance is a huge one. I mentioned earlier about investor confidence and investor understanding, but that when you're considering building a facility, that extends towards project finance as well. And because of the novelty of these e-fuels facilities, there isn't a huge amount of precedent to go off. So that is a huge challenge. And I think the second one is about not really getting carried away with these projects. Whilst it's fantastic and we need to have SAF as a high percentage as we possibly can, we also really need to think carefully about how we go and build these huge infrastructure projects and how that reflects onto our future business models, because we're all producing SAF because we want to help solve climate change, and we need to weigh up the risks of building those huge infrastructure projects in a way that means that they're sustainable and we can continue deploying them, which then doesn't risk sort of public or ill perception about if they don't quite work as planned.
Thanks, Sophie. Yeah, and I think yeah, definitely, you know, the legislative part does play a role in that and in boosting confidence around investments for some of these new projects. But I think still sticking with the EU rules and some of the possible additional hurdles that one might face when looking at e-fuels and direct air capture. So under the EU rules at the moment, eSAF and other e-fuels will have to use CO2 from biogenic sources or from direct air capture by 2041. But of course, the amount of biogenic carbon available will be capped by global biomass limitations. So that means that large-scale eSAF production will hinge on direct air capture. So what's your view around the development of this technology and availability of biogenic CO2?
I mean, for ASAP DAC, we are using both biogenic and direct air capture sources of CO2. So we really feel like having a blend in this early stage is really, really important. So for our facility, 10% or around 10% of our carbon dioxide will be supplied by Mission Zero's direct air capture technology, which is really exciting. And we feel like that's really important to have it as part of that overall blend of CO2, because it, like you said, with the EU rules, it will be becoming more of a prevalent technology as time goes on. So for our designs, we thought, actually, do you know what, we are going to include this quite early on, and we're going to be a big supporter of direct air capture technology in the early stages. So whilst the economics are less favourable currently, if we can build that into our designs now, in the future we will be in a much better position to incorporate the DAC element. And then when we're thinking about the climate implications of direct air capture, the payoff of using existing CO2 already in the atmosphere and recycling that, in a sense, is environmentally much better. But it also changes the way that you then go out and sell your power to liquid fuel, because you can sell it in a slightly more, well, just a more positive way, because the emissions reductions are greater than what they would otherwise be. But we do recognise the importance of creating SAF, full stop, I guess. So we're a big proponent of all different technology options, but we do have a soft spot for DAC.
And there is another thing to consider. In the UK, we have quite a lot of energy from waste plant. Initially, somebody talks to you about burning municipal waste in a facility. You kind of, my initial impressions were perhaps quite negative. But when you dig into it, a lot of what's being burned is actually biogenic, so cardboard and food waste, for example. And then they're looking to pull out plastic and actually sort the waste streams going into these facilities. And I was quite surprised to learn that some of these energy from waste plants, around 50% of the CO2 coming from the facility can be considered biogenic. And in the UK, the subsidies through the Department for Energy Security and Net Zero, they're funding decarbonisation projects involving carbon capture, and so some organisations are looking at setting up carbon capture and utilisation hubs, and potentially if you have a carbon capture and utilisation hub where the vast majority of the CO2 is going to be sequestered underground, and the UK through the North Sea, we've got many options there, but we can potentially book and buy the biogenic portion of that CO2 and use that in our facility. And so if you're looking at where can we get the CO2, if you expand that to energy from waste facilities, the UK is quite well positioned for that.
Right. Okay. Yeah, I'm actually learning quite a lot. I mean, a lot of the work that we're doing now is around, existing technologies, especially when it comes to pricing, like HEFA, or we're seeing a lot of more co-processing alcohol to jet. But it's really interesting to hear about these developments in these more advanced technologies, which sounds like they are actually a lot closer than one would think. Then it's just a matter of really scaling it up in terms of volumes, also in time to meet these mandates. Yeah, I think this has been really, really, really interesting. So we're running out of time for today, but I really want to thank you both for making the time and joining us today. It's really been a pleasure.
Thank you so much. We appreciate it.
Thanks.
Yeah, thank you.
Yeah, no, absolutely. And thank you for tuning in to this podcast. And for more information on Argus global coverage of the sustainable aviation fuel market, please visit the Argus SAF Hub. Thank you and see you soon.